Before I start, I'd like to make note of a couple of things that are coming up. In the spring, the chapter is going to have a public lecture and probably panel discussion on something mathematical related, and mathematics reality. This is the hope. We're going to see if we do it. Also, Denise Ludwig. Denise, are you here?
Yeah.
Okay, you're giving a talk in January?
Oh, beginning of February.
Beginning of February.
Ambrose, yeah.
Okay, that's the St. Ambrose sponsored talk, and that's
Yeah.
going to be the topic of what?
Oh, genetic engineering.
Genetic engineering, very, very topical subject. So I recommend that you look up that talk when it happens. You know where it's going to be?
It will be at St. Ambrose, so they're at Holy Name Heights now.
St. Ambrose Academy is now located in the old Holy Name Seminary building, which became the Bishop O'Connor Center, which became Holy Name Heights, and is now being used for St. Ambrose Academy for foreseeable future. So very good. Again, indeed, my talk is equipping mankind for the future through the science, engineering, vocations, the reflections of an aging engineer. This title is a little incomplete because I'm actually going to be hitting with several different things in succession. The first thing I want to do is talk about the nature of scientific knowledge and its relation to reality. If you're paying attention to the bishop's homily today, he kind of brushed on that a little bit. Followed by the purposes of science, engineering, and technology, and the roles of us in those vocations. What we're supposed to be doing in these vocations is the science, engineering, technology, and mathematics. And finally, the title subject is what challenges our species, Homo sapiens sapiens. It's always great when you call yourself the wise, right? Homo sapiens sapiens will have to face if our natural existence as a species is actually extended far more than we believe it might be. Again, my purpose is not to convince you of anything in particular. At least maybe toward the end I will. It'll come up. But it's really to stimulate your thinking. I really want to have people thinking deeply about these things and not just sort of going along with the flow and just sort of doing one thing after another as society presents it to you. There's a lot more to it than that. So, I'm going to make this confession, or some people treat it as a consertion. We in the sciences do not truly and completely understand anything. Of course, that leads to the question, does anybody understand anything? But that's another matter. But we certainly do not, I'm going to defend this statement here. So, okay, so we're going to have a flirtation of metaphysics here in the first part of this thing. We understand from reason and faith, that is revelation, that, among other things, inter alia, God is uncreated, non-contingent being, and is spirit, that is a non-corporeal in his own nature. He's pure act and has no potential. Okay. This is the language of philosophers. It's very dangerous when engineers start using the language of philosophers. But we don't really have any other language to deal with this. As engineers, you're always dealing with act potential. Something is in one state or another state, it switches states. But God is, we call, pure act. And because he simply is, he doesn't have flow of time, because time is a property of matter. Something philosophers knew 2,000 years ago, but scientists are only catching up with in the past couple of centuries. God is a trinity of persons sharing one and the same being in a communion of love. Some people say this is only by revelation, but I would hold actually this can be sort of hinted at via reason as well. There is reason to think this, to come to this conclusion by reason. And finally, the overflow of love within the Trinity is expressed in part in the creative act. All things that are not God are part of creation and are contingent upon his continuing act of will. So anything which is not God is contingent, whether angels or us or the rock or whatever. It all depends on God's continuous act of willing us into existence. This is the philosophical point, and is sort of the part of the philosophical basis behind the Christian religion. This is in part because of the, how should I say, the providential interface between Judaism and Messianic Judaism, and of course early Christianity and Greek philosophy. A lot of things got sorted out when the wise men of Greece and the wise men of Christianity came to realization that who God and what God is. This implies that matter, the stuff we deal with, the stuff with which we are made, with which we work, the corporeal is implicitly or explicitly a product in some way of the non-corporeal. Stuff, the stuff we make of, we are made of, the stuff we are, its existence is derived from that which is not corporeal, and it's not matter. Okay. Again, more philosophy, more metaphysics. So how is the transition from spirit to matter made? Is this even a meaningful question? This is where it gets dangerous talking to an engineer. Have an engineer talk about these things. Okay, so at the base of reality, we have uncreated being, or God. We understand from the order of being that there are also non-corporeal spirits that are created. We call them angels typically. And then at the top we have what we call what philosophers call secondary matter. That's the matter we deal with, ordinary matter. Okay, whether it's at the molecular, the macro level, or the micro level, it's still matter. It's called secondary matter. Philosophers posit the existence of primary matter, which is a philosophical concept which doesn't really mean much to us in the sciences, but it's in a sense, it's an attempt to try to maintain the identity of a thing as it undergoes certain transformations. For example, if an electron and anti-electron merge, they produce a gamma ray of, I think, 511 keV, and then that gamma ray can, in some circumstances, can then produce an electron and anti-electron. The philosophers would say that the identity between the original electrons and the ending electrons is this thing called, this concept they call primary matter. Okay, we don't deal with it, but it's there. The question that often bugs me is, how many layers are there here between God and secondary matter? I've asked Andy Teeter to give me this answer. He's so close. He has not given me the answer yet. I'm going to guess 7 just because, but I have no idea. But the fact is, there are layers. Apparently layers. There seem to be layers, but there's an argument whether you can use that terminology or not. We'll find out one of these days. I often ask God, please explain this to me. I'd like to know what matter is. What is the stuff we're made of? I mean, how is it? Why is it? And I remember reading a 1950 science book called The Design of the Universe, and at one point people were speculating that matter, particular particles, were caused by disturbance in the ether. There were vortices in the ether which were matter. But then now the Michelson-Morley experiment has people think there is no ether. That's under debate too, I suppose. But the fact is, we really don't know. Okay, but this is the typical approach of the physical scientist and engineer. We observe phenomena in nature. We see what's going on. So you take a glass rod, you rub it on your cat. The cat bites and scratches you. You say it's a bad idea. You grab a silk cloth instead. You rub the silk cloth on the glass, and you find them might attract each other. Okay, why is this? Okay, so you observe something in nature. Then you develop a model. All right, what can we do to explain what's going on? So I think it's Faraday who came up with the word charge. He said, okay, there's a charge which moves between the glass rod and the silk cloth, or between your feet and the carpet, or whatever it is, where you find things getting this electrostatic charge, which is find shocking every so often. And then, as things go on, you can develop a mathematical expression of the model. Okay, so you work with the model, you work with your model, you see how it explains reality, and if it explains reality in a predictable fashion, then you can actually come up with mathematical equations which will successfully predict the outcome of the natural event if your model is accurate enough. Of course, models have different levels of accuracy. And because a model which works well in one circumstance does not work well in another circumstance. For example, we know that F equals ma. You push on something with a force, the object has a certain mass, it has a certain acceleration. And that model works fine, unless of course you start getting close to the speed of light. Then you have to add a Lorentz term. Okay, things change. Or atoms and molecules. The Bohr theory had circular orbits, electrons in circular orbits around nuclei, and that kind of worked, but then found it didn't work. And now we have the quantum mechanical explanations and orbitals that have weird shapes and probability functions instead of physical objects going around a thing in an understandable fashion. So then you can predict behavior from models good, and then of course these things are we call in the area of science. So this is where the science comes in, the study of nature and its understanding. And then of course once you have a model which works, that can predict things, then you get engineering. That's literally true.
Yep. Yeah.
All right. So once you have the model, once you can actually accurately predict what the things are going to do in nature, then you can actually exploit it. Engineering, right? I didn't put this next, but the next things are regulations and taxes, but that's another matter. So descriptive predictive modeling is not the same. It's not an explanation or understanding. Being able to predict something doesn't mean you understand it on a fundamental level, right? And I think this is an error that we in the sciences often make, because we can predict things, because you have equations and computer codes that these accurately predict reality in many respects. We think we understand it, but we don't. We're simply able to use it, which is good. I'm not complaining. But the fact is, we have to be honest with ourselves and say we don't really understand. Okay, before proceeding, I will note that as Catholics, as Christians, as friends of God, it should be fairly obvious to us that all legitimate human activity, certainly any activity of moral import, ought to have God as its source and as its ultimate end in the teleological sense. This is as true for us in the pure and applied sciences as it is true for those in any other legitimate human occupation. When this is forgotten or overlooked, the experience of history and our current world situation demonstrate that we will wind up doing or facilitating great harm to our fellow men. Right? And this is something that we have to bear in mind. As Catholic scientists, as Catholic engineers, we are more aware of this and should be more of it and act on it. So, a dictionary definition of science might read, because it does read, I got this out of a dictionary, any system of knowledge that is concerned with the physical world and its phenomena and that entails unbiased observations and systematic experimentation. In general, a science involves the pursuit of knowledge covering general truths or the operations of fundamental laws. This is taken from Botanica.com. It's a limited definition, but it will do for now. The definition of engineering might read, and one of them in fact does read, the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes, or works utilizing them singly or in combination, or to construct or operate the same with full cognizance of their design, or to forecast their behavior under specific operating conditions, as all respects an intended function, all as respects an intended function, economics of operation, and safety to life and property. Now, the Engineering Council, Professional Engineers, actually defines engineering. So, getting to the realm of personal opinion, it seems to me that a more complete definition of science for someone who is Catholic and is therefore aware of the deeper and divine aspects of reality, the definitions might read more like this. Try it again. Pick up my glasses. Science, an intellectual system that is concerned with the acquisition and systemization of knowledge, especially the created world, using the powers of observation and reason, thus giving man an enhanced understanding of creation and the Creator. This, I hold, is a more complete definition of science. Nothing should be done, no intellectual endeavor should be undertaken, or could be literally be undertaken, if there's not some understanding of the relationship to the Creator. Right? A parallel definition of engineering might read thusly. Engineering, the art of applying the knowledge acquired by the practice of science to the solution of problems of a technical nature for the benefit of human flourishing, thus giving glory to God. The doctrines of the Vatican Council, I think Lumen Gentium sort of draw almost an equal sign between the happiness of man and the glory of God. All right. So, but that is truly what engineering should be. So, this leads directly into the consideration. In fact, I'm overshooting here. This leads directly into the consideration of the role of technology, which is the immediate fruit of what can broadly be described as engineering. Okay. Now, technology comes from the Greek word tech, which means art, so it's kind of a circular definition almost, but it's the artwork, making things happen, doing things, right? So let's step back and consider why man exists. We know the answer to this question. Baltimore Catechism, published AD 1891. In the first chapter, question and response number 6. Why did God make you? God made me to know him, to love him, and to serve him in this world, and to be happy with him forever in heaven. You know, and I listen to people in the world generally scratching their heads wondering why they exist. That's the answer. Simple, childlike, because the book is written for children. But the fact is, it is that simple and that glorious, even when stated in a way meant for children. It's that easy, in a sense. We don't have to wonder. We can wonder at the fact that we exist and wonder at the fact that God does this, but we know why we exist. And I have to feel bad for people who don't know. It's a horrible way to go through life. So turning back to the matter of technology, from Christian revelation, we understand that all things that are not God, are the result of the free creative act that is the consequence of the excess of love among the persons of the most holy and undivided Trinity, that among those things that are created are the physical universe in which we reside, and we ourselves, that is man. Okay. So we are not just created by God, but we are the product of excess of love. This is part of the Christian revelation. While certainly Judaism has it that God loves man, in fact, some of the language used to describe that is almost pornographic if you read the Song of Songs. But the idea that this love is an excessive love, and we're a product of an excessive love, is, I think, a Christian idea specifically. Islam does not have the idea, for example, that God loves man. At least not as the way that Judaism does or Christianity does. For a Muslim, God loves man the way we love a pet. Okay, it's a different kind of affection. Right? The opening chapters of Genesis depict God giving Adam the task of maintaining the garden and instructing Adam and Eve to be fruitful and multiply. Meditating on these considerations raises the possibility that we, mankind, not only reside or exist in this physical universe, but are part of the continuing creation. So we're not just here. We're doing work as part of God's continuing act of creation, creating this edifice that we can only see a very tiny part of in our very brief time here. And you like to think of the medieval craftsmen as working on a great cathedral. So think of the men who built the Cathedral of Notre Dame de Paris hundreds of years ago. Many of them died before it was completed. Many people died before it was completed. Many of them worked on obscure parts that people would never see. But nevertheless, they were working on the cathedral. We, as in the sciences and engineering and technology, are devoted to understanding nature and working on that cathedral, which is all of creation. And so, all things considered, I think it is safe to say that God takes delight in there being more people than fewer people, more people that potentially be in loving communion with the Trinity. It's a dangerous statement to think what God satisfied with God's, is thinking, if you will. But he did say, "Be fruitful and multiply." That's part of Revelation, and so I think it's not unreasonable to think that God prefers there to be more people than fewer people. So, to me, this is the key. This is the key to understanding what the purpose of technology is. In my opinion, technology's ultimate purpose is to allow more people to exist and have the potential for ultimate loving union with the Trinity than would be possible without it. I think this is the fundamental purpose of technology. There are more of us living comfortably, and there's nothing wrong with living comfortably, right? More, the planet can exist more. It can support more people with the technology. Farming, obviously, is a big thing. You can put more people in the city if you have a water distribution and sewage system. I mean, there's all sorts of reasons that technology aids the welfare and people, and just the sheer number of people that can actually exist at any given time. So let's consider man's longevity. I don't know how well this doesn't really show very well, I'm afraid. But this is a chart starting with the Big Bang, and so this is the whole thing, and then these are expansions of the last section here. So this says So this presumes that all of time is in 1 month. From the Big Bang to the present day is 1 year, 1 year. This is the month of December, okay? So here you have the Big Bang and the formation of stars and galaxies and whatever. And then planets. And then here we have, the formation of animals and so forth, finally getting to hominins and man. And then this is, I'm sorry I didn't show up as well, the final minute of the month of December in this extended calendar. And this has basically all of human history. And then the final second is basically past 400 some odd years. So, I mean, we've been around for a very teeny, tiny fraction of the, 13.5 billion year history of the universe at this point. I mean, really a very, very tiny fraction. So concerning our future, I get the impression, it's a general presumption that we won't be around very long. I mean, in religious terms, we always think of the second coming of Christ as being something which is very evident, very soon. And of course, back in the days of the apostolic times, we were thinking that's why St. Paul for a while was saying, don't bother getting married if you're not married unless you have to. Chill out. And then sometime later saying, 1,000 years is like a day with the Lord, right? I mean, there's always this constant tension. There's always people thinking that Christ is coming tomorrow. And it's all going to be over. And someday he will. No, that'd be right. Suppose, and of course, if you look at secular people, secular thinking, you seem to see the same assumption. There is a graph like this that I found, which has not just history but also the future going forward, and it seems to, in fact, it does assume that man's going to be around for a short time, and everything we build is going to decay, in some thousands or millions of years, and then we're just not going to be around to do anything about it. And I find that interesting. And of course, it's always possible. I mean, but the Earth is going to be around for another 4 billion years before the sun swallows up and destroys it. So the Earth's going to be here for a while. But suppose the presumption is wrong, and we continue as a species for millions of years. All right? It's not the way we think normally, but I think we have to at least consider that as a possibility. So, question is for me, how can we in Anno Domini 2024 help prepare the way for man to survive and thrive and be faithful disciples of our Lord Jesus Christ in AD 20,024, 20,024? What do we do now? Okay? And I think something regarding technical solutions, and I'm going to first talk about the technical solutions, we have to bear in mind that our task is not to come up with definitive solutions at present, as you do not know what technology will look like in the very distant future, or for that matter, even in the not so distant future. Think of someone in the 15th century considering the possibility of giant cities with millions of people, and then wondering how are you going to move all that horse excrement out of the streets. And maybe he developed machines in his mind to move all this horse excrement, He would not have understood the possibility of internal combustion engines or electric motivation, all these things which were completely outside their imagination at that point. And we're in the same situation. We have no idea what is going to happen in the future in terms of groundbreaking discoveries or new devices. So we're obviously not going to come up with the solutions, in particular for people in 20,000 or 20 million years. Okay, at present, for the longer term issues, the best we can probably do, technically, is to identify as many potential issues as we are able and to establish research and development initiatives that can deliberately begin to lay the groundwork for eventual solutions by collecting data and by seeking to understand the challenges with increasing depth as time goes on. So we can look around and see what the trends are and see, okay, what's going to work in the long term, what is not going to work. We may not be able to solve the problem, but we can start collecting data and understanding it. The process will go on over many generations if you do it right. One exception to this is if societal habits of a sort that would prove deleterious to future generations are identified, mitigation techniques can be designed and implemented in the present day. For example, consumption of non-renewable substances such as helium, by the way, is a non-renewable substance, or coal, or any of these other things, right? We know we can't pull stuff out of the ground forever. Please note that I'm here referring to technical solutions, to technical problems. I will address certain non-technical aspects later on. So these are the categories I'm thinking of. They come to mind first, that we have technical challenges coming. Energy, obviously. Water, food, recycling almost everything at some point. Planetary climate engineering, and repair of the human genome. Of course, this is not exhaustive, but I'm going to consider these things sideways, starting from 5, going to 1, and then 6 for various reasons. So planetary climate engineering. Ice ages are cyclic. We are still coming out of an ice age. We're still in a warming trend from the Wisconsin glaciation. But because of the orbital mechanics of the Earth and the Sun, there will be future ice ages. This is a chart of ice ages going backwards in time. So the past is toward the right. And you can see how the temperatures and such varied with time and really bounced around. So this is right now we are here in this warming trend. So we're sort of climbing up here, but there will eventually be additional ice ages. We, as much as people are frightened by global warming, that possibility, fact is we really can't do well with an ice age without a lot of work. And they're coming. Okay, so that is something, for example, that we'll have to deal with at some point. Recycling almost everything, so we don't have, there's really nothing on the planet that we can sort of just consume and throw away indefinitely. We will have to learn to recycle everything. So in the event that mankind persists for timescales of geological significance, then truly nothing can be considered disposable or truly consumable. All things used by men will have to exist or be designed such that they can, by natural or artificial processes, be altered in chemical structures such that they can be formed into other useful items without harm being done in the process. Okay. So this is something we can start thinking about now. It doesn't. People are thinking about this already. We don't have to wait until the problem becomes intractable. Food. A presumably growing population of Homo sapiens will need increasing volumes of food. Also, over geologically significant timescales, the traditional means of growing food may be hampered by naturally occurring extreme variations in the fraction of arable land available, atmospheric composition, air temperatures such as ice ages, and so forth. So, mitigation strategies and new ways of producing food will have to be explored. So, how do we get around these problems when they arise? What other ways can we use to produce food? Whether it's multi-story urban farms or whether it's actually food that's somehow manufactured, that remains to be seen. But these are things you have to think about. Water, unless your physiology changes drastically, we're always going to need water. And this is just an idea, a graph which shows you how much water is fresh. So this is total global water. It's mostly oceans. There's the fresh water there. And the fresh water is divided between glaciers and ice caps, groundwater, and a very thin layer here, which is surface or other water. Okay, so we're getting thinner and thinner. Then that surface water is divided between ground ice and permafrost, lakes, and atmospheres and things like that. So the amount of water we can actually get our hands on in relation to the whole is small. Okay. So it's hard to see how we're going to deal with this as the population grows, unless we start doing long-term desalinization of one sort, or start burning hydrogen in the solar outside the planet and bringing water in that way. I don't know. We don't know. But the fact is, this is something we're going to have to deal with. Energy. Now, of course, energy is always a concern, and that's becomes kind of personal at this point, because this is why I went to graduate school. Now, this is just a random graph we pulled off the internet. And there's a date here where the energy consumption and the energy supply in fossil fuels splits, and you have a shortage. The date when this happens is always going to vary at some point because who you talk to and what the latest discovery was. But sooner or later, this is going to be the case. We're going to not be able to fuel ourselves with fossil fuels anymore. This is where it gets personal for me, because I became interested in nuclear fusion for this very reason, I think I was in high school. And that's why I came to UW-Madison, because they have a very good nuclear fusion program here. And just a quick, this is probably the only technical detail I'm going to get to in this entire talk, is, and almost any step it seems the need eventually taken to deal with this very long-term challenges that presented so far required energy. So all these other things that I talked about, producing more water, producing more food, all these other things are going to require substantial energy inputs one way or the other. All right? And I think the only thing we now know about at the moment that can do this in the long term is nuclear fusion. In nuclear fusion, here's a rough sketch of the solar nuclear fusion process. You start with 4 hydrogen atoms, and they go through a fairly complicated process, and you come up with helium-4 on the end. And there's a difference between the hydrogen mass and the helium mass. It's a very small number. But when you multiply the small number by the square of the speed of light, it becomes rather substantial. You okay there?
A little beep going on.
Yeah, I heard the beep too. I don't know what that is. It's not me as far as I know. Anyway. All right, so here's some nuclear fusion and their fossil fuel equivalents. I made this table when I was at UW some time ago just to sort of explain our motivation. If you take 100 cubic feet of these gas mixtures, deuterium, or deuterium and tritium, or deuterium and helium-3, or helium-3 and helium-3, 100 cubic feet. Now deuterium, by the way, for those who don't know, is hydrogen with 1 neutron. Tritium is hydrogen with 2 neutrons. Helium-3 is a helium nucleus with 1 neutron missing. It's extremely rare. If you just take 100 cubic feet of this gas at room temperature, so imagine a box on the floor that's one foot high by 10 feet wide and 10 feet long, filled with these gases, right? And you fuse all the gas in that box. You're doing a very small quantity, right? If you completely run this cycle, this fusion cycle on the gas in that little box, that's equivalent to having the energy release is equivalent to 19 million cubic feet of natural gas, or 152,000 gallons of heating oil, or 3,640 barrels of oil. I think that barrel grows 55 gallons, or 753 U.S. tons of coal. Right? And these other numbers are similarly large. That's why we're all going crazy trying to make nuclear fusion work. You know, it would just really put energy problems to rest if we can actually do that. So, folks at UW-Madison, Jerry, are you here? Jerry Kosinski? Okay, he's not here. My boss was thinking of coming today. A couple of guys at UW-Madison, my boss being one of them at the time, and a colleague named John Soteris were working on the idea of mining helium-3 from the moon to produce for nuclear fusion purposes. The reason the helium-3 fusion has various advantages. And I asked him about this, and I got this email from them. So the whole idea, the lunar helium-3 idea came not from a conversation, but rose very late at night in December 1985 as I was getting ready for bed after an evening of dealing with editing of a final report for the technical planning activity at DOE committee. It occurred to me that the moon had been collecting the solar wind, including helium-3. Helium-3 is an intermediate product of the sun's nuclear fusion reactions, and a lot of it gets thrown off the sun in forms of solar wind. Because the moon possesses neither an atmosphere nor a magnetic field. My wife woke up and I told her, I just had the strangest idea. And that was the beginning of this effort to look at nuclear helium-3 on the moon. And what they did is they went back to the Apollo data to see if their suspicions are correct. So they looked at the assays of samples taken from the moon by the Apollo astronauts, and sure enough, there's lots of helium-3. It doesn't exist on the Earth except as a consequence of decay of nuclear weapons. Okay, so this is where the helium shows up in this solar fusion reaction. It's an intermediate product. So the moon may be the major source of new energy supplies for the next 1,000 years. So at the current rate of world consumption, the helium-3 supply on the moon would supply the Earth for 1,000 years. But it doesn't end there. The gas giants also have huge quantities of helium-3. And where'd it go? It disappeared on me, didn't it? How could it do that to me? So anyway, the gas giants, the ones that are mineable, it's been uncooperative. The helium-3 supplies there would supply the Earth's needs for 1 billion years. Okay, so there would be no energy crisis if we can do that. And that's actually something which is practical. Now, the number 6 is the touchy one because this is the one that's most fraught with moral problems, potentially, which is the repair of the human genome. And I'm not a biologist, so I'm an engineer, electrical engineer starts talking biology, also dangerous. But it seems to me, rightly or wrongly, that due to the intervention of civil engineering and medicine, okay, civil engineering has probably saved more lives than physicians have saved more lives than physicians because just sanitary sewers, plumbing, and things like that. People are now living to and through reproductive age who would have died in prior decades or centuries, including, by the way, myself. I would have been taken up under any number of infections that I had as a kid if antibiotics had come to my rescue. That seems likely. As a consequence, genes that might reasonably be reckoned as potential cause of bodily defects are being propagated throughout the human population. So the success of civil engineering, civilized society, medicine, and so on and so forth, especially going forward as you understand the human systems more and can actually provide more detailed medical care, is also working against our genetic health. So in the very long term, it may likely be necessary to take steps to repair the human genome, either by selective marriage or by technical innovations that would operate on chromosomes to begin with, including those cells that produce sperm and ova. And this is where it gets to be very dangerous morally because it's easily abused and will be abused, unfortunately. Now, I said by selective marriage, in my family history, going back several generations, they didn't know genetics per se, but they understood the blood getting weak, and they understood the effects being propagated through mating and reproduction. And there were apparently 7 sisters in this one family, and apparently they decided that things are getting so bad, they ordered the sisters to not get married, and they didn't. They lived single lives because their elders told them, just don't do it. That's what I mean by selective marriage. We don't have, at the moment, we don't have the discipline society to do that, but that kind of thing could be done. So this is the kind of thing we're going to have to work on. Now, this brings me on this last slide to one major non-technical point I would like to make regarding the role we Catholics, we Christians of any sort, we friends of God of any religion, who have vocations in mathematics, the sciences, engineering, or technology, simply must play if we're not to fail God nor our fellow man who is depending on us to help keep human society intact and thriving, whether or not he realizes it. We have to accept our role as the consciences of our professions. Let me repeat that. We have to accept our role as the consciences of our professions. There is nothing inherently, how shall I say, there are no inherent moral guarantees to what engineers and technologists will do with the knowledge obtained by science. Edward Teller, who developed the hydrogen bomb, once was complaining to some people who were against using it or developing it. Said all their objections are merely moral. There's a problem there. I had a conversation at the UW-Madison Hospital when there was a presentation on human embryonic stem cell research, and the people in the room were generally very in favor of it. And of course, human embryonic stem cell research, you produce a human embryo in a petri dish, and then you destroy it to extract cells and keep cultures going. So you have to create a human individual, then destroy the individual. It's an inherently immoral process. And they were complaining about us who were objecting to this. The guy's name was Ian, I believe. I forget his last name. But I walked up to him after the talk and I said, I think you should meet the enemy. And I introduced myself to him. And I discussed this with them. Well, their attitude was, if it's not illegal, we'll do it. If you don't like it, make it illegal. There's no sense of, okay, there are moral laws to be followed, even if they're not expressed in civil law. We have to provide the consciences for our professions. And right now, it's an uphill battle. Second, we have to stop being nice and ceding professional space or prestige to or following example of people in our professions who make noise in public spaces, actual metaphorical, and who fail to refuse to engage the moral law. Okay. We Catholics, especially, I think, in the United States, have this habit of being shy and retiring. You don't want to offend anybody. whether it's something as simple as making the sign of the cross in public, or dating our dates of our slides with AD and BC. I mean, I rail against this. I was talking to a Catholic colleague of mine in, I think, the zoology department, and he's giving a talk someplace, and he's using BCE, and I said, why are you using BCE before the Common Era? Because in my book, that's hate speech. You're refusing to acknowledge the obvious fact that we date our time from the birth of Christ. This is just a fact. The whole world does this. Yeah. And he said, what's what my colleagues do? His colleagues are not Christian. Well, why are you following their example? So, we have to get used to being in the public square. We belong in the public space. We are not foreign invaders in the public space, or in the professional space. Our values are not this weird thing that others have to simply cope with. If we do not speak up, if we do not bring Jesus explicitly or implicitly into the public discourse and guide technical development, then we're going to wind up living in hell on earth, as has already been seen on the earth in various places. When you have when you have governments that hate God taking over things. And that's my final word to you. That's my final message. The one thing I'm trying to convince you of is that we have to be politely in your face with our society, and don't be afraid to bring the values we have into the public square. Thank you.
I did. I wanted to track that with the BC and AD argument.
Mm-hmm.
That is, it was developed by the Venerable Bede or Boethius or someone to that.
Venerable Bede, it was actually Dennis Exiguus who
Okay.
suggested using Common Era and before Common Era initially because he realized the calendar was off by a few years.
Oh, I see.
But that never got adopted. People didn't care. The BCE, CE garbage started not too many years ago when people who simply hate Christianity didn't want to refer to
Okay.
Christian years. And this is a relatively recent development because there's a synagogue in my old neighborhood which states proudly on the cornerstone AD 1956. and then Hebrew year, which I forget, it was 54 something.
Right.
So this is a relatively recent thing where people are trying to push this out. This is just another sign of anti-Christian behavior. We really cannot tolerate that for their good.
Right.
It's not because we're offended by it. We might be. The fact is, if you let society do this, we're going to go. I mean, look what's going on now. It's become a politically hot thing to say there are only two sexes. Only women can have children. I have an acquaintance on social media named April Hutchinson, who's a Canadian female powerlifter. And she was suspended for 2 years because she objected to a so-called trans male competing in her thing. So, I mean, a trans woman, is a male. It's a male pretending to be a woman. And yet, stating this obvious fact is now, troublesome. So this is what happens if we abandon our posts in the public square.
Right.
We go crazy. The society goes crazy.
I was going more along the lines of citation. The BC and AD has a longer history, and to not give credit to where credit is due, it kind of defeats the purpose of for someone to impose a CE or BCE on top of what has already been established seems to take away credit from where credit is due, when as scientists it's supposed to produce new work based on what someone else has already done in the past, and it kind of contradicts the spirit of referencing to something that has already been labeled and identified.
Yes, it does.
Yeah.
Any other questions or comments? Yes, Tim.
So it's something I've been struggling with for a while. Maybe you can help. So I go to your human genome. So NASA has a project, or has been funding work on how to modify the human genome to allow to create humans who can live long in space and on Mars. How do we decide if that's a moral or immoral thing to do?
Well, you know, I could probably say that off the top, right off the bat, that designer humans.
That's not design, I don't know if it.
Well, I mean, you're designing a human being for a specific purpose to live in a specific environment, optionally.
Right. And they don't have to, they could live like we do.
Yeah. And the thing is, though, the people, you're making the decision for people who don't yet exist. You're going to design, you're not taking an adult and saying, okay, we're going to modify your genome so you can be in this environment, and it's a voluntary thing.
But how is that different from modifying my genome to prevent me from getting cancer?
Well, because you acknowledge that, say, getting cancer is a defect. Having only one leg is a defect. And we can't, and this is the question we have to ask, and I'm not saying I have the answer to this, that it definitely is moral. This is something we have to work through, because there's getting to the point where we might be able to do this kind of thing. Okay, if you know that this couple that is married has a gene defect that's going to result in deaf children. Okay, is it correct to even regard deafness as a defect? As an engineer would. Well, it doesn't meet specification, right? It's defective. But people are not things, so we have to have a debate if it is a defect, if in the sense, or is this the way someone's supposed to be? Because some people's vocations are sort of built around their apparent defects. But I would say more speaking is that saying that this individual is going to have this apparent defect, and if we fix it, he won't have this defect, and his life will not be as hard, is a bit different from saying, okay, we want people to go populate this planet, and so without their consent, because they don't exist yet, we're going to make the decision where they're going to live for them by adjusting their genes.
You don't have to make the decision where they're going to live. It's simply the fact that, if they decided they wanted to live on Mars,
Mm-hmm.
they could survive the trip, which is a pretty bad trip.
Yeah.
Think about it, right? With all the dangers, but also living on Mars. But they don't have to. They can simply stay here on Earth and live a healthy life.
Well, that would really.
So,
then you have to ask yourself, what is the change being made? Is the change going to make life more difficult for them if they stay here or not? If it doesn't, well, then you might be in a different
but
moral.
you see where my struggle is.
Yeah, I do, and that's something we're going to have to work out, I think. And that's part of, we're going to have to be part of our job. I mean, another thing that's going to be happening, well, I'm not going to do that. But yes, these are things that are coming up. It's going to be a frightening and interesting time in the next couple of centuries. Yes?
Okay, so my question is about energy storage specifically. Energy storage in respect to the fact that you can work in nuclear fusion. What is your opinion about how we're currently? I feel like I guess in my opinion, energy storage, nuclear fusion would obviously eliminate needs for storage, right? So
Mostly, yeah.
mostly, right? Things like electric vehicles that have these giant batteries that we're creating that these cars probably won't last maybe 5 or 10 years, and then when those die, because they're not cars. We live in a consumer society first, also. So
Which is a problem to begin
right?
with.
People are like, oh, my car's out of date, I need a new one, and they'll just get a new car. But then these batteries that are just these massive batteries
Mm-hmm.
that have been elaborately made and designed by Elon Musk's Tesla company, how does I don't know, how does somebody reconcile the potential toxicity of that being in the environment versus something like nuclear fusion, the rods or whatever the things. Nuclear fission right now is rods and stuff, storing long-term toxic waste.
Mm-hmm.
What is I guess your opinion about which one seems like a lesser evil in terms of the potential for other future environmental damage from a toxic waste standpoint when we're
Mm-hmm.
producing all these mass production of all these vehicles that are just gonna sit in a landfill at some point. How is that better than just using nuclear fission for electricity while we're developing nuclear fusion still? What are the
Okay, I can talk to some of that for
Sure.
a number of reasons. One, I was actually working in the hybrid electric vehicle team at UW-Madison, and I was a designated battery expert.
Sure.
And I learned that the primary barrier for a general purpose electric car is the battery capacity. It's just not there. It still isn't,
Right.
really. There's a trade-off. Now, people also misunderstand the proper function of electric vehicles because it's being sold as this thing which is good for the environment.
Right.
That's not true.
Right.
Electric vehicles have a role where if you're going to be in a densely populated urban area with lots of vehicles, then electric vehicles make sense to use in those areas because then they're not throwing pollution out the tailpipe.
Sure.
Now the pollution will still be generated, but it's going to be by the coal-fired plant
Right.
outside of town, where you can have scrubbers and things to try
Right.
to mitigate it. Nuclear fission. Now the environmental toxicity from my view from a coal plant is much worse as a nuclear fission plant.
Right.
If I had to live next door to a nuclear power plant, I'd much rather a nuclear fission plant than a coal plant. One of the reasons being there's actually less radiation coming from the nuclear plant than the coal plant. Because when you burn coal, there is trace amounts of radioactive materials in the coal, which get burned and then thrown out the exhaust pipe into the air.
Oh my goodness.
All right. So I mean, I think nuclear fission is fine. The problem we're having with nuclear fission is that it's a political problem.
Right.
The fact is, we could easily deal with the radioactive waste problems and the toxicities and all those
Sure.
other things.
Yeah.
Also, nuclear fusion plants, when they are finally built, will solve that problem too, because we'll be able to burn the actinides and reduce them to a more stable, less long-lived radioisotope.
Okay.
Reprocessing is a real thing. We could do it, but the political will is not there because.
So is it your opinion then that like it's mostly just like we have to convince the political side of things that like EVs aren't like God's gift to mankind and or that like the saving grace that is going to pull us out of this quote unquote environmental crisis that we're in and like all this other like.
No, they aren't. They at least not anytime soon. Again, because the battery's not there. I mean, look, your vehicle, your general purpose gasoline or diesel vehicle.
Right.
It's amazing.
Right.
You can get in this thing, and you can drive to the corner store for a bottle of milk, or you can just drive to California.
Right.
I mean, that's amazing, and you can
Right.
do so comfortably and with reasonable chance of survival, and
Right.
and there's other things. I mean, that's an amazing technological achievement.
Sure.
All right. Electric vehicles. Okay, you can do that, but you have to stop along the way in some very long recharging stops.
Right. Yeah, but it's not even that though. It's like we don't even have the electrical infrastructure in this country to sustain everybody having an electric vehicle. We don't.
No, we don't.
I work in the civil engineering field, and these vehicles are so heavy that our roads aren't designed to support those kind of vehicles driving on them all the time. So we have to replace all of our roads, we have to replace all of our electrical. Like that's a huge task, and that's going to take a lot more environmental stuff. It makes me mad that people are just like, EVs are so great and they're so wonderful, and I'm on the soapbox a little bit, but
This is another part. This is one of the things we have to also deal with as technologists. And so, we have to inform the public of the truth of things, because the people who report the news, they don't really know much of anything about technology or about religion, but they're compelled to speak, and so part of our job is to try to inform the public of what is real and what is not real. There are people who think we're going to run the entire country with wind turbines and solar photovoltaic panels, and that's going to supply enough electricity to run our homes, our factories, our fleets of electric vehicles, and our water heaters. Because as of a few months ago, at least, it's going to be illegal to purchase the gas water heater after 2027. So the policy of the past 4 years has been to try to make us more and more dependent on the electrical grid. At the same time, trying to ramp down the high level generation capacity we need to maintain such a grid. And that's pretty steep. That's part of our job, is to try to straighten that out. Okay, just one or two more, because people want to eat. I don't want you starving and falling asleep on you. All the way in the back. Then you.
On the occasion that I do find myself in a situation where I should speak up with like the Catholic Christian perspective,
Mm-hmm.
I usually find myself unprepared, or my mental state is like too emotionally charged to have like a productive response. Do you have any suggestions on how to prepare yourself for those moments?
Well, I mean, there is no shortcut. You just have to do the reading and the discussing with people who are knowledgeable. I mean, you just have to learn it. Because the world is full of misinformation out there, and lies and misunderstandings, a lot of misunderstandings. You just have to put the time in to do the reading, and to even deal with people, talk to people who do apologetics. There are a lot of resources available now for people who do any kind of apologetics, which is what you're talking about. as far as your emotional state goes, learning to control yourself is a virtue you have to learn, and they say that you learn a virtue by practicing it. Learning not to go beat the guy over the head as much as he may deserve it. Not to beat the guy over the head when he says something stupid. And ma'am, you had your hand up too. You, yes.
I think I have a question that relates to these two things. So if you count the cranes, building cranes on campus and where they're at,
Yeah.
School of Medicine, Business School, and soon to be the School of Engineering.
Mm-hmm.
That's where the cranes are. That's where the money is, right? And what we actually need, it sounds like, are our philosophy colleagues, our linguist colleagues, and our colleagues in history to help us communicate the problem and the solutions.
Mm-hmm.
We're not putting any cranes up in liberal arts.
Well, you don't need as much equipment as we do, honestly.
I just wonder if one of our moral obligations is to lift up our colleagues that still represent the humaneness of our education.
Well,
We'll keep our language more humane and our ability to speak to non-scientists.
yes, and that's a very important thing to do. Now, I have to say this is kind of mean, but a lot of the trouble we're having as a society is coming precisely from the philosophy departments and the political science departments and the history departments, because they've been infiltrated, honestly, with people who have agenda, and that's no secret. So I'm not going to lift them up until such time as they get their act together. A lot of the trouble we're having, all this stuff of political correctness and now the woke movement, all this stuff had its roots in the liberal arts departments of American universities. Yes, I agree with you, and to me, art is one of the highest expressions of humanity, more so than engineering even, believe it or not. But we have to have people whose minds are sane. And the problem is now we can't be entrusting these things to these people as you're describing until such time as they are sane. See, as physical scientists, we have the advantage that we can't speak nonsense too long before running headlong into reality. If you want to go around claiming there are multiple sexes or multiple genders, that gender and sex are different in human beings, which is ridiculous. You can do that for quite some time and make quite a bit of money and get on talk shows and spout things. If someone wants to decide there's no such thing as gravity, all they have to do is invite them to step off a cliff and demonstrate the process, and that problem solved one way or the other, right? The people in humanities don't have that advantage. They can go on spouting nonsense for a very long time before they're corrected, and often not until a great deal of harm is done. Our challenge is to be moral, because we have the tools. Right? Nuclear physics can be used to power civilization. It can also be used to destroy civilization. As the bishop said, science doesn't tell us what is good or what is right. It really tells us it's kind of what is. And engineering tells us how to do it, but it doesn't tell us what's right or what's good. None of these things even can explain why we should exist or continue to exist. Yeah, I agree with you in part, but we have to do a lot of repair work in our philosophy, history, and political science departments before we trust them with that kind of task again. Yes, Bell.
Want to quickly respond to the young man who was looking for ways to evangelize.
Proceed.
With as much prudence as you can. I encourage you to do as I do and waste a tremendous amount of time on the internet. You can engage the world in comm boxes after articles. This gives you time to, look something up before you respond. Your interlocutors will be crazy, and you can be calm and sane. You're not going to change anybody's mind, but there is always a gallery of people who just read the comments. And as you are, and that's your audience. You just simply lay out the argument, be reasonable, explain the truth, apply a few facts and references to establish your cred, and you will find you change hearts out there that you don't know. But every once in a while, that other guy will, give you a thumbs up on your comment, and you touched somebody. So there's opportunity, especially for young people who are a lot sharper on social media and such than I am. And you can bring what you have in terms of tech knowledge and Catholic wisdom and share it with the world.
I'd add to that
Really?
podcasts. Like, there's a ton of podcasts out there that are really great. So I don't have time to read or spend time on the internet, but I do have a 30-minute commute each way, every day, and I listen to podcasts. There's a ton. I don't know if I have specific science in Catholic science ones, but like Pints of Aquinas and What Catholics Should Know and Dr. Retrees, and there's like tons that you can try and just look up Catholic science podcasts. I'm sure you'll find some.
Very good. Now it's going to be lumped toward. Oh, yeah, Sarah, one more.
Yeah, because when you were mentioning how that one guy said, well, we have a law against it. Well, I did a little bit of research, and about 10 years ago, the Supreme Court rejected a ban on embryonic stem cell research. Maybe it's time we bring that back to the Supreme Court and lawmakers since we have a new Supreme Court members, we have new lawmakers, we have a new executive branch 10 years ago.
Well, it's a legal strategy that makes sense, but I think more fundamentally, that's only sort of a holding action. We have to get our colleagues to understand that this is wrong and should not be done, regardless of the law. I mean, that's what we really need to do fundamentally. I mean, physicians should not be doing the surgeries they're doing now. Sex changes, so-called, things like that, or abortions or whatever. It should be unthinkable for them to do that. That's what we have to do with our colleagues. Some things have to be unthinkable to do because they're just wrong. Now, it's almost lunchtime. I suggest we, before you leave, if you're not on the email list, please leave your name, address, and telephone numbers. Switches over there, Caitlin. And so we can contact you in the future. So let's stand and say grace and then begin. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Bless us, O Lord,
and these thy gifts which we are about to receive from thy bounty through Christ our Lord. Amen.
Thank you all. I hope you enjoyed my talk on these matters to get through it okay.
Yeah, thank you.